Right. Today's lesson, we're going to be looking at cracking, and I will do it for both AQA and Edexcel because I'll make it very clear to you when I'm talking about your syllabus, because it's the same thing. However, in AQA, they do 2 types of cracking, and in Edexcel, they just do 1. So we're going to do it all in one lesson. So what is cracking, really, and why do we need cracking? That's the important thing. So we've previously looked at fractional distillation. Fractional distillation took a mixture of kind of long alkanes and separated them into long and short ones. Now, the problem with fractional distillation is that it produces more of the long ones and less of the short ones. There's a lower demand for the long ones, and there's a higher demand for the short ones. The reason for this is that the short ones have lower boiling points, so are better fuels. So you can see a dilemma, supply and demand. There's a large supply of ones we don't want, and there's a low supply of the ones we do want. So we do cracking in order to produce more short ones. Now, to put that into one kind of big answer, I have it in our notes here. Why is cracking important? This is why it's important. A high demand for short chain alkanes as they're better fuels, but have a short supply. Cracking produces alkenes as well, which can be used to form plastics via addition polymerization, which we'll cover later. So the main thing is that cracking produces short chain alkanes and short chain alkenes. Okay, that's why cracking is important. Now, go back here. Cracking is a type of thermal decomposition because what you're doing is you're taking a long alkane, so long chain alkane, and you're making it into a short alkane and short alkene. You must always produce at least one of these. You could produce multiple alkenes, that's fine, but it must be one alkane, one alkene. Now, we haven't actually done what an alkene is, but we will in the next lesson. But an alkene is essentially with a double bond. Alkane is with a single bond. Alkanes have a general formula like we did before, CnH2n plus 2. I'll just tell you that alkenes are CnH2n. You will see why in the next lesson. But the main point is that this is a thermal decomposition reaction because whichever syllabus you are, you need heat. And if you put heat into something to break it, then it must be an endothermic reaction. It is absorbing heat. And it is called cracking. So before we get into details of the syllabus, we should know how to write an equation for these kinds of things. So say you took C10H22 and you want to crack it. You're allowed to crack it whatever way you like if they haven't specified. Ideally, don't put it into 9 and 1. Crack it into some other way. So I'm going to pick 6 and 4 because 6 plus 4 makes 10. So applying these formulae, if I pick C6, if I'm going to make my alkane first, I'll need to double the 6 and add 2, and I get 14. Plus, now the other one, you can actually work it out by subtracting. So 10 minus 6 is 4, and 22 minus 14 is 8. Magically, alkenes are CnH2n, so 4 times 2 is 8 actually works. So this will be the alkene, this will be the alkane. Now, this is not the only way to break this. You could instead have done this. You could do C6H14, but you could have made 2 of this. This is actually called ethene. In the exam, they will usually have a gap for you to fill in. The main purpose is that you make sure that the atoms add up to the total. They will rarely give you complete freedom to just break it into whatever you want. So what they might have done for this question, as an example, would have been to write nothing here and to leave a gap and say what goes here. So your purpose is to just do 2 times 2 is 4 and then take it away from 10. So then you get 6, and then 2 times 4 is 8 and take it away from 22. and you get 14. So it'll all be about filling the gaps. Okay, so it's not a very difficult task. Now, let's get on to the types of cracking as such. So we will first do the cracking that's present in both AQA and Edexcel. And that is actually this one here. Okay, the main difference in Edexcel and AQA is that in Edexcel, they want you to actually know the name of the catalyst, and they want you to know the temperature. Whereas in AQA doesn't require you to know it, Edexcel does. So for Edexcel purposes, 600 to 700 degrees Celsius is the temperature. And the catalyst is going to be alumina or silica. In AQA, we just say high temperature. So high temperature and then pass over hot catalyst. We don't specify the catalyst. Okay. So once again, Edexcel, learn these two. In AQA, you just have to say high temperature and hot catalyst. Now, how it actually works, if your teacher shows you in the lab, is that you soak some mineral wool into paraffin. So paraffin is your long chain hydrocarbon that you're trying to crack. You then get some porcelain chips, which is actually acting as the catalyst here, and you make sure it's really hot first. This has to be done first. Then you heat up your mineral wool and it will vaporize. So the aim is to vaporize, heat and vaporize the alkane, i.e. high temperature. So this will turn to a vapor. As it passes over the catalyst, it will crack and it will turn into an alkane plus an alkene. The alkene happens to be a gas and it's passed over here. It goes up and pushes the water level down and it collects in here. So this is how it's shown in the lab. They've used the example of the 1, 2, 3, 4, 5, 6, 7, which is actually heptane. So they've taken the C7H16 and they've turned it into C2H4. And then you could just do the difference. 7 minus 2 is 5. 14 minus 4 is 10. Wait. Did I do something wrong? 1, 2, 5. This is 12. Yeah, sorry, I messed this up. This is C7H16. So that should have been 16. Because you have to make sure you can't just get two alkenes. They have to be, one of them is basically 2 times 2 is the CnH2n formula. This one is the CnH2n plus 2. So 5 times 2 plus 2. Now I'm going to teach the AQA people, just Edexcel people, just for 1 minute. I'll just show them AQA people. This one is called catalytic cracking. And that's the one that you do in Edexcel as well. Then just for AQA people, the other one is called steam cracking. And the only difference is that you pass over steam, not pass over a hot catalyst. First point is still high temperature, heat, and vaporize the thing that you're trying to crack, the long alkane. Okay, so just know these two conditions if you're doing AQA or steam cracking. Otherwise, catalytic cracking, these are the conditions and requirements. And that solves the problem because it makes the shorter alkane, which is a better fuel, lower boiling point. Sorry, this one, the shorter one, it's not 7 long, it's 5 long, so easier to burn. And it also makes an alkene, which is used to make plastics in later lessons. Good. Don't worry about this. Okay, so next lesson, we will all be covering alkenes, obviously, for both syllabi. So see you next time for the lesson on alkenes.